The app we built thus far works, but there is one thing which we can change, or which I at least want to have you think about. On the orders screen, we changed this to be a stateful widget simply because I wanted to use init state here. And by the way, as I mentioned in a couple of annotations at the top of the video during the videos, if you are using listen false as we're doing it here, you don't even need that hack, and you would be fine running that code without that future delayed around it. So you could actually get rid of all of that. Of course, you then can't use await here though, because you're not in an async function, and turning this into an async function is not what you should do. But of course, you could then use then here to run your code that should run once the future is complete. So you could move that set state call here into here, and this first set state call is obsolete because we don't need that. This will run before build runs without that future delayed workaround, so we can just set is loading to true, then have this here, and this would work as well if you use listen false here. That's also the difference to modal route off and so on, which didn't work here in init state. There we simply don't have such a listen option. The provider package simply internally gives you an option to opt out of certain functionalities that would normally be connected with the inherited widget and this tunnel, which is established with the help of context. And with these missing features, which you deliberately opt out of with listen false, you can use provider of context here, because you basically use only a limited set of the features of that inherited widget thing behind the scenes. So you could do that here. You could do this in all places with provider off. You can't use listen false on things like modal route and so on. That's not supported there. But that's not the main thing I wanted to focus on. It's just something I again wanted to mention here. The core thing I wanted to mention is that we're building a stateful widget here simply such that we can use init state to initialize our data. And I think that makes sense because we want to have a place in our app where we can make that call, which only runs once when this screen gets rendered. For example, making that fetch in the build method would be horrible because that method runs way too often, and actually we would even enter an infinite loop if we start calling set state in there, or if we then fetched our orders and build runs again and we start fetching again and so on. So making the fetch and build certainly is not an option. There is, however, an alternative to turning this into a stateful widget and using init state, and it's that alternative which I now want to show you. So let me comment this out here in init state, and therefore we have an empty init state method, which we of course could also remove. And let me show you that alternative. Here in that body, in the end, the content we render depends on the question whether we're still fetching data or whether we already got a response, right? So what we can do here is we can use a special widget which is built into Flutter, and that's the FutureBuilder widget. The FutureBuilder widget takes a future and it then automatically starts listening to that. So it adds the then and the catch error methods for you, you could say. And it takes a builder which will get the current snapshot, the current state of your future, so that you can build different content based on what your future returned. So here we can set up a future, and our future, of course, is the future returned by provider of fetch and set orders. So we can copy that line here and then go down here and configure that as the future, because fetch and set orders, of course, does return a future. So that's the future for our future builder. Now with the future set up, we also have to define a builder. And that's a builder as you generally already know it. It's a function which gets executed on your behalf. It receives a context, and here you also receive an extra argument, and that's your current the data currently returned by your futures. So a data snapshot, you could say. This should then return the widget you want to build. And now the widget you want to build, of course, simply depends on the state of that future. So let's actually use the more complex or the longer function definition without that arrow, so that we can write a multi-line function body. And here we can first of all have a look at the data snapshot to find out what's in there. The data snapshot here is of type async snapshot, and if you add a dot after it, you see that there you can find out if you have an error object, or the data which you retrieved, and also what the current connection state is. And that tells you what the future is currently doing. You can compare this to connection state. And for example, there you can find out whether it's currently waiting, so whether the future hasn't resolved yet, or whether it's done. And when it's done, you will have to check whether you got data or an error. So here we can check if data snapshot connection state is currently equal to connection state waiting, which means we're currently loading. So in that case, of course, I want to return this centered widget here. So I will return this here. Else, I know we're done. And then you could check if data snapshot error is equal to null, in which case you know you have no error, or other way around, if it's not equal to null, in which case you have an error, and then you want to do error handling stuff here, which I'll not do here, but which you could do. Alternatively, else, you know you have no error, and then here I want to return that list view. So let's get rid of that down there now. We don't need is loading anymore. So here I'll just return the list view builder. And in case we should have an error, I'll just return a centered widget with a child where I say text an error occurred, just to have something on the screen and return some widget in that case. But I focus on a success case, and here we return our list view builder with the order data, which should now be available because we're done fetching our orders. Now, one important note about this setup though, right now we would enter an infinite loop here, because when this is done, fetching and setting the orders, it will notify listeners, and since we set up a listener to orders here, our whole build method would run again. We would build a new FutureBuilder here and send a new request, and that would keep on going. So the solution here is to not set up the listener up here for the order data, because we don't need the order data up there, but simply use a consumer of the order data in here, in that case here, because only here I'm interested in order data. So here we can set up a consumer of our orders, where we in the end define a builder where we get the context and our order data then. And now here it is where I actually want to render that list view, because that's now the place where we actually need our orders and where we want to set up a listener. And important, of course, here you also have a third argument, that child, that static child, which never changes, which you could use. Now we should have a setup which actually works and fetches our orders without entering an infinite loop. And just to check this, I'll also add a print statement here in the build method, building orders. So this should now not run all the time. And let's now see whether that works. So here I'll go to my orders. We see the spinner, we see the orders. And back here we see that this was only executed once. And this is now the more elegant alternative to using a stateful widget just to fetch orders and show a loading spinner. And the advantage is also that we don't just save that useless transformation to a stateful widget, we also don't have to manage the loading state on our own, because we're letting the FutureBuilder do that by checking the connection state. So now what we can do here, of course, is we can get rid of init state and of this is loading property, get rid of our state class, and convert this here back to a stateless widget as it was before. And now this is a very lean widget, of course. And we can do a hot refresh to have the same application as before, but now with a more elegant setup for our orders. And obviously, you could use such a FutureBuilder as we're using it here in your other widgets too, either to turn them back into stateless widgets, or if you had reasons for making them stateful widgets, even in such cases, to not manage the isLoading variable on your own, but instead let the FutureBuilder do that. I'll leave that here, and I'll also leave the other approaches in this app so that you can see and check both. But using the FutureBuilder is definitely the approach I would recommend because it's so elegant and it utilizes the tools Flutter gives you. As a side note, it of course also avoids rebuilding this entire widget tree here just because the loading state changed. Instead, it will really just rebuild the parts that do need rebuilding. So that's another benefit we get here. So we added FutureBuilder here, and here everything works as intended. However, I want to highlight one potential issue you could be facing in other applications, and therefore a better way of using FutureBuilder. The way we use it here works absolutely fine in this app and in this widget. But if you had something in this widget which causes the build method to run again, some other state you're managing or anything like that, then fetch and set orders would of course also be re-executed, right? Because if build runs again, this entire code here runs again, and therefore this method would run again. This of course means that a new future would be obtained here, and that of course in turn means that a new future would be obtained, and that of course in turn means that this HTTP request is sent again, and so on. And that is something we might want to avoid if just something else changed in this widget, if there's no reason to fetch new orders. Let's say you were presenting an overlay, a dialog to the user, and hence the build method executes again. You definitely don't want to fetch new orders just because something else changed in this widget, which doesn't affect the orders. Therefore, it is considered a better practice to obtain this future differently, even though, I will emphasize it again, this approach will not cause any problems here since we have no other state changing logic in this widget here. But if you had that, a better way of getting and using that future would be to convert your orders screen to a stateful widget, which I quickly do here with refactoring. And with that converted, in your state class, you should add a property of type future, for example, named orders future. Then you add a new method which returns a future, which you could name obtain orders future, like this. And in this method, you then return the result of this call to fetch and set orders, which of course will give you a future. So you return this future here. Now, as a last step, you should add init state here. And before you call super init state, you set orders future, so this property, equal to the result of calling obtain orders future. So with that, we just have a clean way of getting our future and storing it in a property when this widget is created. And then you use this orders future property in your build method as a future here for the FutureBuilder. By using this approach, you ensure that no new future is created just because your widget rebuilds. Again, this is not a scenario we have here. This widget won't rebuild unintendedly. But if you had the scenario that a widget could be rebuilt and you don't want to fetch new orders just because something else changed, then using this approach is better and ensures that no unnecessary HTTP requests are sent, and therefore this is considered to be a good practice, which I also wanted to show you.